Hello, and welcome back to the channel. Today, I created a new playlist in my channel called LeetCode, and I plan to populate the playlist by deep diving into the solutions to LeetCode problems. So, please make sure to subscribe to the channel for interesting upcoming videos and give a thumbs up to support the channel. Alright, the first and most popular question from LeetCode is the two-sum question. Here is the link to the question, and here is the screenshot of the question. Basically, for a given array of integers and a target integer, we want to return indices of two numbers that add up to the target integer. I will walk through the question and examples in detail in a minute. But before, I just want to let you know that I uploaded both Python and C++ solutions into my GitHub repository, and here is the link. I have also posted the link in the video description below. Let's go back to the question one more time. Let's say we have an array of integers and a target integer as inputs. We want to return the index of two integers such that they add up to the target. For this question, what constraints do we have? The minimum length of the array must be 2, and the maximum is 10 to the power of 4. The elements of the array must be between -10 to the power of 9 and 10 to the power of 9. The target integer is constrained between -10 to the power of 9 and 10 to the power of 9. There is only one valid answer. Finally, can we come up with an algorithm that is less than n squared time complexity? Let's review the first example. We have 2, 7, 11, and 15 in the array of integers, and the target is 9. Let's index the array, zero-based indexing. The index will be 0, 1, 2, and 3. Then, the only possible solution for this is 2 plus 7 is equal to 9. Therefore, the return indices will be 0 and 1. Or, in another example, let's say we have an array of three integers of 3, 2, and 4. The target is 6. From the array, the only possible integers are 2 and 4, and adding them up gives the target. So, the return indices should be 1 and 2. Or, in a simpler case, with two integers of 3 and a target of 6, the return indices will be 0 and 1. Now, the question is how to come up with an algorithm that has a time complexity less than n squared. Let's pick this example and see how we can implement a simple algorithm to do that. Basically, the most intuitive way to solve this problem is to check whether or not every combination of two values sums up to the target value. This is a brute force approach. So, we loop over all elements in the array and check every combination in the list by making another loop over the remainder of the array, excluding the giving element. This requires two loops to check all combinations, and the time complexity for this approach will be n squared. But we can do better than this. Let's see how. Okay, let's try the same example, but let's use a dictionary in Python or hash map this time. Basically, by making a map, we will make pairs of keys and values from the array. I would like to emphasize that we could add the keys and values into our map by iterating through the array first, but there is an easy way to do it. Remember, we can't use the same index twice. That's why making the map at the beginning is not a good idea, because it might pick the same key and eventually pick the index twice. Instead, initially, we say our map is empty. At iteration 0, we get to the value 3 from the array and check the difference between current value 3 and the target value. So, the difference will be 6 minus 3 is equal to 3. Since, initially, our map is empty, we don't find 3 on the map. Then, I am going to add 3 to the map as the key, and the index will be 0. Now, I'm at iteration 1 and checking the difference. 6 minus 2 is equal to 4. Since 2 doesn't exist on the map, then I will add the 4, the difference, and index 1 to the map. You might notice that I store the difference instead of the actual value from the array. because I know the difference for sure exists somewhere in the array. However, you could store the actual element from the array, and the results will be the same. Finally, at iteration 2, we have 6 minus 4 is equal to 2. The key 4 exists in the map, then the return indices will be the index corresponding to key 4, which is 1, and the current iteration index, which is 2. For the worst case, the time complexity will be O(n). Okay, let's jump into the implementation and see how we can implement this algorithm in both Python and C++. Let's write the Python solution here. Here is the test case example for the input array and target value. The first step is to create a dictionary. In step 2, we loop over the number of elements in the array and compute the difference between the target value and the current element in the array. If the current element does exist in the dictionary, then we will return the index corresponding to the current element in the dictionary and index I. Otherwise, we will store the difference and index I in the dictionary and move to the next element. Let's run the test case here and see if it passes. It's good. Now, let's submit the code. Great! Almost 94% faster than the submitted solutions. Here is the C++ solution. First, initialize the map and the vector of return indices. Then, similar to Python code, do loop over the number of elements, compute the difference and check if the current element exists in the map. If so, return indices, otherwise, store the difference in the map and move to the next iteration. Oops, I got an error here. Let's submit it again. Cool. Thank you, and see you in my next video.